Hello, and thank you for joining us today for spacer cable versus tree wire. Before we begin, a few words about the webinar technology. This platform allows our audience to be more involved with the presentation and, more importantly, allows you to watch this event the way you want to watch it. To begin, feel free to customize the webcast console. You can move windows around by dragging on the title bar or resizing the windows by clicking on the lower right corner of any window. You'll notice a toolbar at the bottom of your console, and these buttons allow you to open and close widgets on your screen. And by the way, we invite you to get social. If at any time during the session you hear something that's interesting, feel free to tweet it to your followers. If at any time you experience difficulties with the audio or advancing the slides, press F5 to refresh your webinar console. We appreciate your feedback, so please click on the red survey icon and complete that form. Now for today's presenter. Brian Trager is the Director of Technology and International at Hendrix Aerial Cable Systems. He received his Bachelor of Science and Master of Engineering degrees in electric power from Rensselaer Polytechnic Institute in 1979 and 1980. He also has a master's degree in business administration from the University of Pittsburgh in 1986. Mr. Trager has held various positions in engineering, consulting, and management at American Electric Power, Cooper Power, and Fisher Pierce. He's also taught electric power engineering at Ohio State University and West Virginia University and Pennsylvania State University, in addition to teaching courses to utility clients. Brian's an active member of IEEE and has authored over 50 technical papers and articles along with other national and international organizations. With regard to electric power line specification, design, construction, and management, Brian has worked on projects funded by international aid organizations to meet the growing demand worldwide through the expansion of electric power infrastructure. He has brought to fruition numerous high-reliability power distribution projects at various sites on 7 continents over a period spanning 37 years. For the past 20 years, he has been solely dedicated to aerial covered conductor systems. So with that, let us begin. Take it away, Brian.
Okay, thank you for that wonderful introduction. It's a pleasure to be here with you this afternoon. For those of you who have chosen to join us, thank you very much. The topic of discussion today is spacer cable versus tree wire. Two very distinct options. We're going to talk about definitions, go through similarities between those two construction options, talk a little bit about what the differences are, the mechanical configuration and support, what we have in terms of site preparation and maintenance. Look briefly at the tree trimming considerations, look again at the animal, weather, and environmental performance of each construction option, get into a little bit about the construction challenges, the costing, the reliability and quality of service, and see if we can work on a summary. Okay, so definitions. First of all, tree wire versus spacer cable. What are the differences? Spacer cable is 3 heavily covered conductors supported by a messenger and separated and hung by spacers, as we can see here in the left photo. While when we talk about tree wire, we have those same heavily covered conductors strung in an open wire configuration, the same as bare wire on cross arms with polyethylene insulators. Again, when we talk about tree wire, it's going to use either standard cross arms or armless brackets, and we're going to have to use polyethylene tin type insulators. You can't use porcelain. You can use porcelain if you want to burn down your conductor in several years. This is what tree wire looks like. It doesn't look a whole lot different than a bare wire construction system. The truth is you can use shorter cross arms. Okay. How about spacer cable? Spacer cable is heavily covered, non-shielded phase conductors. You can see the phase conductors here, held together and supported by a high-strength messenger. The messenger is on top there. That messenger has three functions. It's the mechanical support member. It essentially holds everything up. It is your phase. It is your shield wire. It's also your ground wire. It also holds everything off that may be falling on it from above. Here's the spacer. They are installed about every 9 meters, every 30 feet. And then we have very few mechanical components, brackets being tangent brackets, angle brackets, and dead end brackets. We also have single phase spacer cable, and you can see there on the left and the right those photos. So, what is the same between tree wire and spacer cable? Well, the first is that they're both National Electric Safety Code compliant. Safety Code 230D says covered conductors shall be considered bare conductors for all clearance requirements except that between the spacing between conductors. That can be reduced below the requirements for open conductors. So they are both National Electric Safety Code compliant. What else is similar? How about the conductor design? It's completely identical. Those three layers of the insulation. It allows closer spacing of conductors, withstands temporary contact with tree branches and other ground points. It's UV stable and tracking and abrasion resistant. The other similarity is the insulation layers, okay? So first we're going to have a semicon shield over the aluminum. That's going to smooth out the electric fields. It's going to reduce partial discharge when I'm in contact with a ground plane or a partial ground plane. That semicon shield over the aluminum is going to increase the BIL, and it's similarly going to lengthen the useful service life. That second layer is the inner layer. It's called the natural unfilled polyethylene or high molecular weight poly. It's an excellent insulation, high BIL, high 60 hertz withstand. And the other benefit is that it's very soft. It's going to allow us strippability, very easy to strip. The outer layer is going to be the high density polyethylene, which has several functions. It's the highest density polyethylene that we're able to use. It is going to be track resistant. It's going to be abrasion and impact resistant and have a very high UV stability. It's a chemical UV stability. It's not UV stability by using carbon black. What else is similar? The installation thicknesses are exactly the same for tree, similar sizes, 336, 477, 556 and above. We're probably going to be able to use double AC because it does have the rated tensile strength. And conversely, for spacer cable, even though we're always using double AC, you still have the option to use triple AC or ACSR. It's mechanically viable. Obviously, the stronger conductor has the rated tensile strength, but it's not economical. It's not beneficial from an ampacity standpoint, but it may be beneficial from a stocking standpoint. We have at least one or two clients that use ACSR for spacer cable and for tree wire, because a lot of utilities will use both. What are other differences? Well, let's take a look at tree trimming, site preparation, and maintenance. When we look at tree trimming for bare wire or tree wire on the left, you can see standards require us to have 2 meters or 6 feet on the side of that bare wire or tree wire. And on top, we're going to need 15 feet or 5 meters of clearance. And that's quite a swath taken out of that tree. If you take a look at the spacer cable on the right, first of all, we're taking the cross arm off, and we're putting the bracket on the street side rather than the load side, so we're saving 1, 2, 3, maybe 3.5 meters on the side of that tree. Secondly, the limbs that we have taken off for the bare wire or the tree wire, we can leave, because if they do get wet in a rain shower, and perhaps sit down and touch that messenger, the messenger can handle it from
a mechanical standpoint because it has a very high rated tensile strength. And secondly, it can handle it from a electrical standpoint because it's grounded every 500 feet or perhaps every pole in high lightning areas. So we will also be able to let that foliage grow back until they're just about tickling those phase conductors. So we're saving 50 to 80% of that foliage. And after a couple of years of conversion from one to the other, the canopy is just completely different. There's no comparison whatsoever. In the previous slide, we took a look at the tree being on the side of the tree wire or bare wire. Here, you can see it's bifurcated. So this is the big V in the tree. I don't know how great that looks. Take a look on the right side, the spacer cable. We are essentially feeding right through the trees. So it's hardly noticeable, if you will. I wanted to talk briefly about maintenance. Tree trimming. So for tree wire, obviously periodic, clear the large limbs, keep the foliage off the phases, certainly the large limbs off the phases. With spacer cable, we want to do the same thing. But they say with spacer cable, you're going to double the tree trim cycle. If it's 1 year, it's going to go to 2 years. If it's 3 years, you'll go to 5 or 6 years. And certainly you're going to be saving 50 to 80% of the foliage. So there's quite a bit of difference there. Spare parts, I have the spare parts that you need here for tree wire, obvious, and the spare parts you need for spacer cable. And I put one yellow box there saying that the difference is that tree wire will require more patrolling, since while those large limbs lying across the phases really won't cause outages, assuming they'll take it off eventually, they will eventually cause abrasion and possibly insulation damage. Okay, how about costing? You folks can write into me, tell me if I got this right. This is what I made up. This is what I get from my experience. It may be true at your utility. It may not be true at your utility, or there may be some other differences. What I had to do is use a baseline, do a cost comparison to bare wire. So when I looked at material cost, and when I say material cost, I mean first cost. The tree wire is going to be about 15% higher than bare wire at 15 kV. The spacer cable is going to be 25% higher than bare wire at 15 kV and perhaps 10% higher than tree wire at 15 kV. And that cost premium, that material cost premium, that first cost premium will increase for higher kV classes. And again, if you want to enlighten me or disagree with me or fill me in, you can send in some comments here. The site prep for tree wire is going to be the same as bare wire. There's absolutely no difference. Spacer cable, the site prep is going to be significantly less tree removal. Tree wire, the tree trimming is going to be the same as bare wire. Spacer cable, you're going to save 50 to 80% of that foliage and double your cycle. Installation, this is arguable or debatable. I'm saying the tree wire is going to have about the same installation time as bare wire, whereas spacer cable, it's going to be the same or less depending upon crew training. We have crews that only do spacer cable and rarely do tree wire or bare wire, and they say spacer cable takes less. When we have a utility that's doing spacer cable for the first time, obviously there's a training period involved. How about maintenance? With tree wire, I said tree wire is going to have the same or more maintenance than bare wire because you really have to keep a good eye on the tree limbs sitting across those phases. They're not going to cause an outage, but they may cause abrasion and damage. Spacer cable is going to be the lowest maintenance of all options. Okay, how about differences in animal, weather, and environmental performance? We'll take a look first at bird and animal contact. With tree wire, yeah, we get some good performance. They're going to provide temporary fall protection. The only fly in the ointment there is that the absence of the covering at the conductor ends does pose a safety hazard to birds and animals, so that's an issue. Whereas with spacer cable, it is completely covered and eliminates that safety hazard to birds and animals. I threw in a photo from a very old, I guess a very old newspaper comparing tree wire and spacer cable. And this is one of the historic problems, is that tree wire creates a vulnerability to component selection errors. Here we can see we've got a couple of critters up on the pole, and you can see that they've really nice looking construction, even though they've used porcelain insulators. So the tendency to use wrong components, whether that's porcelain insulators or the wrong dead end shoes or stripping and so forth, these porcelain insulators are incorrect. They're going to end up damaging the cable, end up in faults, end up in blue sky failures, end up in this conductor being on the ground, and hopefully for these raccoons it won't end up being a safety hazard. But hopefully they'll turn around and go back down. Whereas when you take a look at spacer cable, we've seen a lot of nature coexisting with spacer cable in national parks around the U.S. and Canada, Mexico, South America, and the rest of the world. This is by no means a rare photo. Here we've got a bird's nest on the angle bracket for the spacer cable. I would not recommend this. I mean, at some point these birds are going to leave. I would get rid of that nest. But that's something that you'd be able to survive essentially forever. We've got all kinds of photos here. Forgive the Spanish up on the top there. I apologize for that. This is a Tule Lake National Wildlife Refuge. This bald eagle was quite nice to us and landed, but it's interesting to see this. Spacer cable is also resilient to seacoast contamination. Here we have a photo in the North Atlantic in Mass, Maine, New Hampshire, New Jersey, what have you. We have a lot of really rough weather in the wintertime, and that spacer cable is quite resilient to the seacoast salt spray. Let's talk a tiny bit about harsh weather performance. Tree wire, yeah, it's going to be great. It's going to provide temporary fall protection. It's going to be resilient to small tree limbs. However, as we said before, branches may lie across the conductor, eventually causing abrasion, leading to insulation damage and future outages. Fallen trees or large branches may knock the system to ground, resulting in an outage. So in the tree wire case, the conductor is going to break before the pole. The insulator is going to break before the pole. The cross arm is going to break before the pole. The insulator pin is going to break before the pole. It does give you good harsh weather performance, but you've got to look at where you are and what your failure mode is going to be. When we talk about spacer cable, it's certainly more robust than extreme weather. The overhead messenger protects those phase conductors from anything that is going to fall on it from above, whether it's trees or branches or what have you. Usually fallen trees are supported by the messenger, but a large impact may cause that pole to break. Is that good? Bad? That's obviously a problem. It takes longer for that to put it back together. We'll take a look at a couple of photos here. This is something I got out of the Boston Globe, the newspaper, local newspaper here. This was a tornado we had in the north of Boston. And as you can see, everything's torn down. All the trees are on the ground here, and the spacer cable made it. So this was quite interesting. Took a look further at a utility farther to the south. Okay, that took a bit to change the slide here. We'll go back. All right, thank you. This is Pepco. There's a 69 kV transmission line we have in Maryland. We had a tree fall on this. Helicopter patrol got this, called the dispatch center, said, you have a fault. They said, no, we don't have a fault. And they went out and saw the tree lying across the line. They eventually cut that down, never had an outage. If we take a look at a similar situation, this is going to be a national park, Banff, in Alberta, Canada, where they do their spring patrols. And at this single span, you can see they've got, if you look closely, 1, 2, and 3 trees lying across that messenger. How long they were across that messenger, whether it was 1 day or 6 months, nobody knows, but they never had an outage there. And again, we've got hundreds, if not thousands, of these photos. This was sent in from ENSA in Panama. This is the Panamanian jungle, and obviously this is no trivial tree. This fell down on the messenger and no outage. Got it by patrol and eventually removed that tree. This is not a tree trimming seminar here. And here we go. This is a suburb of New York. You can see this is late October, early November photo. It's raining every day. Hurricane season is just about over. High winds. The ground is sopping wet. You can see that this tree is blown over, smashed into this pole, smashed into the messenger, broken the bracket. And if you look closely, you can see that this tree is supported by the messenger on the pole to the right. And you can't see the pole to the left, but it's supported by the pole onto the left. Line crews go out. They have since straightened out this pole. They put on a new tangent bracket on that pole for the spacer cable, lifted the messenger with the equipment handler, put it in the parallel groove bracket, tightened the bolt, and they've never had an outage. So this is what it's all about: SAIDI and SAIFI, CAIDI, performance, reliability. Here's the ultimate harsh weather performance. There's one medium voltage system in Antarctica, and that is at McMurdo Bay, and you can see the spacer cable there. That 15 kV system has been there since the 70s, and it's had excellent performance. So that's the theory, that's the photos, that's what we've seen in the field. How about empirical data? A field study was done. It was conducted by the Europeans, in this case EA Technology out of the UK, which is a research site for the UK, Northern Ireland, Scotland, and Wales. So what they did here is this is a test site in Deadwater Fells and on the English-Scottish borders, 2,000 feet above sea. They had 330-foot spans, very harsh weather, sustained speeds of 50 to 70 miles per hour. Wind gusts up to 75 and even higher than that. That's all they could measure. And the temp dropped to -8°C, which doesn't sound that impressive, but at least cold enough to have wind, ice, and snow. The duration of that study was 6 months, and they specifically wanted to know what is the difference between bare wire. They used Hazel, 60 millimeter squared AAAC. They used 50 millimeter squared tree wire, 15 kV, and 50 millimeter squared spacer cable at 15 kV. Here's a picture of the test site. This was really an impressive place. When you were up here on a clear day, you could see the Irish Sea on to one side and the North Sea off to the other side. It's actually a nice place. Here is another photo of the test site. You could see the test platform. The data collection, they used load cells to monitor the tension levels in the conductor. Each conductor is also mounted with a turnbuckle arrangement to enable tensions to be altered easily, and this was carried out on this platform. So we had quite a bit of harsh weather here, and that's not a very exciting photo, but apparently a photo of harsh weather. Thank you. Okay, I see by the chuckles of my colleagues there. Appreciate that slide. So what do they do here? I said they took data for 6 months, and they took an unbelievable amount of data. Dr. Brian Waring was in charge of this test, and they had a lot of very high-level research people that are familiar with the utility industry. Basically, they took note of the highest wind conditions, the highest ice conditions, the highest snow conditions, and how those conductor tension changed and the sags change. And without laboring through all of that research, there's papers published on that which we can supply if anybody's interested. But I'll give the test results very quickly. They said, okay, well, what happens in my worst wind conditions? They said the spacer cable is on the left. You can see incidence in order of severity. The severity increases along the x-axis, and the percentage of increase in load on the y-axis. they said that the spacer cable, those yellow triangles, always exhibits the lowest increase in load. The bare wire tends to worsen as the loads increase, obviously, and the tree wire is most greatly affected by the wind. Okay, and you can see the tree wire up here. And then they looked at the snow effects on the conductor loads. They said the spacer cable, that yellow line on the bottom, is always the best performer. In most cases, bare wire was pretty good, but tree wire was always the worst, and substantially the worst performer under the most severe conditions. And if I could paraphrase the words of the researchers that were in that paper that they wrote, it said these graphs tend to summarize the data in simple graphical form. However, looking at the data, generally some conclusions can be drawn. The Hendrix spacer cable has performed extremely well in very severe conditions. It has had to withstand wind gusts of hurricane force as well as severe snow and ice incidents. In comparison with tree wire systems, the Hendrix spacer cable has accreted less snow and ice and suffered less from wind loads, especially as the weather conditions got worse. In comparison with the bare hazel conductor, the Hendrix spacer cable has generally performed better under all scenarios. So, moving forward to summarize these three conditions: animal contact, tree wire is pretty darn good, but it's vulnerable at the strip points. Spacer cable, it eliminates or vastly reduces the hazards everywhere. High winds, tree wire does pretty good. Spacer cable has an edge there. Snow and ice, spacer cable has a hard edge. It performs much better. How about construction challenges? Yeah, we wanted to look through a little bit here. We talked about right-of-way conversion or right-of-way construction. Without belaboring these slides, basically they're both pretty darn good in tight spaces. The National Electric Safety Code Rule 234-1 says if you're using a decent covered conductor, you can reduce your clearance to edifice, to a building, whether that's a single-family or multi-story edifice, by 2 feet. So if you take a look at a standard 14-foot alley, you'd be able to get 5.5 feet on either side with a 3-foot for your spacer cable, or your tree wire options. We've done a lot of these conversion projects throughout the north as well as the south and in Canada. Here we've got a 5 to 15 kV conversion. When we upgrade, we have to comply with National Electric Safety Code. They take a look at this job. It's very viable with underground, but very costly as well. Bare wire is an option, but it creates safety issues. You got to go 12.5 feet above the roof, and that creates issues with pole height. Starts getting a little bit tall. Spacer cable, it turned out to be a very easy decision to do that. So spacer cable is a good option with reduced right-of-way, but we have some clients that say, well, yeah, all right, I'll just go with tree wire, and there's no trees in commercial alleyways, so that is also a very nice solution in a reduced right-of-way, as you can see in this photo. When we go with multiple circuits, obviously spacer cable is going to have an edge because I can put all the circuits on one pole and get them down that alleyway. How about long spans? I don't know. When we use tree wire, long crossings have a weight issue. It requires heavier poles. If you take a look at benefits compared to bare wire, we're going to have conductor clashing is no longer an issue. So there are benefits there. When we talk about spacer cable, all the strength is in the messenger, so there's no limit to the crossing length, and the longer the crossing, actually the greater benefit of the spacer cable compared with tree wire or bare wire. This is not an impressive span, it's only 200 meters, but it's a highway crossing. It's also a contamination application, and you can also see that they used it underneath the transmission line. This is a 520 meter or 1,600 feet river crossing, and this was quite a nice job. They cleaned up the shoreline quite a bit, and you can see this is while it's under construction. That's why the stringing blocks or the roll-by blocks are still on those phase conductors. And again, we said when we go with long spans or river crossings, the benefit of spacer cable increases as you start going to multiple circuits. And here you can see 3 circuits on a river crossing out of Evanston, New Brunswick. So how about multiple circuit configurations? Tree wire usually limited to 2 circuits per pole. Feel free to disagree or write in. Spacer cable, there's no limit to the number of circuits on a single pole. Transmission line underbuild is possible. Distribution line overbuild is possible. Substation getaways are possible. Here's a photo of an infamous system. I put 3 circuits on 1 pole. I forget how tall that pole is. I've seen this. It's taller than my liking, and I would say that those, by the time you look at all those guys, it's starting to get quite busy. Where if I try to do the same thing, I can use a much shorter pole and get 5 circuits on it, as you can see here with a substation getaway. There are really no limits here. You can see on the left I've got 8 15 kV circuits. On the right I have 6 35 kV circuits, and again it goes on and on and on. We have this solar facility has 8 circuits on a pole. Here you see 6 on one pole and 5 on another, and these are very heavy 1033 kc mil 35 kV circuits. And then we have other options where you're going in national parks where you got a 69 kV ring on relatively short poles and a 25 kV circuit below it. One thing I wanted to touch on very briefly is storm hardening. What do we do with storm hardening? How is tree wire in storm hardening? I would say tree wire is really tough to storm harden since it has questionable performance in very harsh weather. The only thing you can really do is overbuild your poles, which is a good option. With spacer cable is inherently storm hardened, and if we want to go one step further, we can more so storm harden it by using what we call the flex bracket, which is a bracket that will flex and not break the pole. So we'll be talking about that more in the near future. A lot of those are installed so far. How about construction challenges? Reduced right-of-way. We said tree wire is more compact and allows closer clearances, so it's pretty good for reduced right-of-way. Spacer cable is still more compact. Long spans, they're both pretty good. Spacer cable holds the edge. Multiple circuits, spacer cable is a clear winner because there's no limit to the number of circuits I can put on a pole. Storm hardening, tree wire, it's difficult to weak link as a conductor insulator in the pole. Spacer cable is inherently storm hardened and can be made more so by adding a special bracket called the flex bracket. Let's talk briefly of quality of service. The first would be voltage regulation. Tree wire is no different than bare wire, going to have the same voltage regulation. Spacer cable, because of the closeness of the phase conductors, it's reducing the mutual inductance. The total inductance is reduced. The total impedance is reduced by 15 to 20%, which is going to provide a 15 to 20% reduction in voltage drop compared to bare wire or tree wire, a reduced need for switched cap banks for voltage regulators, better end-of-line voltage, and a higher power factor. So a couple of benefits there. How about restoration time? Spacer cable is inherently reliable, but we said in the case of a pole break, tree wire is going to hold the edge there in restoration time. They're both going to have extremely high reliability. Spacer cable will hold the edge. Reliability. So we always talk about reliability. Reliability is one thing, depending upon where we are, what circuit we are, where we are on the system, the kV level, what that circuit is feeding. You know, the cost of reliability is what it costs to send crews out to find faults, what it costs in terms of lost revenue, which is usually the least important, what it costs in terms of public relations. They used to say, you know, decades ago, the cost of reliability is how many people show up to a rate hearing. the Public Utility Commission, SAIDI, safety and CAIDI, financial penalties, the loss of industrial load, inability to attract industry, and certainly the loss of critical loads, whether that's a hospital, data center, Amazon center, a Google center, a government center, these types of loads. Put together a graph a couple of years ago, and this is not accurate, it's not linear, and it's certainly just made to illustrate a point where we have the cost on the y-axis versus reliability on the X. Bare wire is the cheapest, and it also has the lowest reliability. Tree wire is a bit more expensive, but improved reliability. Spacer cable is a bit more, still more improved reliability, and then we have PACS, pre-assembled aerial cable. So you can look at that and tell me what you think. So quality of service, voltage regulation, spacer cable is going to be 15 to 20% better. Surge protection, spacer cable is inherently surge protection since the messenger is shield wire. Tree wire, I've got too many open points there, so there's some questions there in terms of surge protection. Restoration time, tree wire, I said the same as bare wire. Spacer cable longer if the pole is broken. I would say tree wire holds the advantage there. And reliability and associated cost, spacer cable is better than both bare wire and tree wire. If I could take a look at a quick summary. What we've said in the preceding slides is that both spacer cable and tree wire are adaptable and certainly suitable to a wide range of application areas. The selection between those two options must weigh multiple considerations. The table which follows on the page highlights the choices that will, in general, give optimal results per criteria. And some of this is empirical, some of it's hand-waving, some of it's judgmental or subjective, if you will. But I tried to put this together, and you can decide for yourself whether or not it applies to utility. I said minimal install, time cost, I would say spacer cable is a bit more expensive, maybe same, so I gave them both a check. Inaccessible terrain, they both got a check. Heavily treed, I said spacer cable had the advantage because my concern is heavy limbs coming down along the tree wire and creating abrasion and possible faults later. Animal contact, spacer cable had an edge because it is a closed system. Environmental contamination, they're both pretty darn good. Harsh weather, spacer cable holds the edge from the empirical data that we've seen and the photos and the client testimonials. Restricted right-of-way, they're both pretty good. Long span, spacer cable holds the edge there. Multiple circuits, spacer cable easily holds the edge. Tree wire, restoration time, I would say with respect to restoration time, yeah, tree wire holds the edge. Storm hardening, spacer cable is inherently storm hardened and can be improved with a flex bracket. Voltage regulated, spacer cable is 15 to 20% better than tree wire. And overall quality of service, I gave the edge to spacer cable. And I believe we are ready for Q&A. Forgive me for speaking too long.
No, I don't think it was too long, Brian. I think it was excellent. Thank you for a very interesting presentation. We have several questions that we'll want to get to, and I think one of the first ones, you had several examples of installations in South America or Central America, and one of the questions was, are there any specific differences in installation regulations that are followed in the Central and South American countries versus the U.S.?
Yes, very good question. And Central and South America, oddly enough, follows essentially ANSI standards, IEC standards, European standards, American standards. There is no difference in construction standards in Central and South America than what we follow here in the USA and Canada.
Another question has to do with, are there differences in the insulation standards for covered wires versus the spacer cable?
In installation?
No, insulation.
No, the insulation is 100% identical?
Well, I'm sorry I gave you such an easy question. Another question we had that pertains to standards is, since both are considered covered conductors, is there a difference? Does the NESC allow a difference in the distance that branches are allowed to approach the spacer cable versus the tree cable?
Absolutely, positively not. National Electric Safety Code Rule 230D says covered conductors must be treated exactly identical to bare wires. However, when you move for spacer cable, if you're moving 3.5 meters or farther away from the center of that tree, you're saving 3.5 meters additionally of that tree, as well as what you have on top. Now, if you need 6 feet tree trimming on the side and maybe 6 on the top on day one of construction, you're going to save a lot more with spacer cable over tree wire, because there's going to be no difference between tree wire and bare wire. Secondly, if you want to say, well, I'm going to go back and trim it back 6 feet every year, or every 3 years, or every 5 years because it's spacer cable, that's a wonderful goal. I don't see it happening where I live or anywhere. Usually spacer cable, they let the trimming go quite a bit more than they do for bare wire or tree wire. But does it differ with standards? No. Standards treat them the same.
Cool. We have another installation kind of question. For the 1,600-foot river crossing, how do they remove the pulling blocks over the river?
Okay. What you have in that photo, maybe you did or did not see, those stringing blocks were suspended from the messenger, and the 3-phase conductors were in them. The lineman who took that photo was about to get out of the bucket. We were going to put a large cage, aerial messenger bucket on the messenger. He was going to roll on that messenger across the river, successively removing the stringing blocks, going a few feet forward, putting a spacer on, moving forward, removing a stringing block, moving forward again, putting the spacer on until he gets to the other side, and then remove that aerial messenger bucket.
Well, it seems clear now. Another question is, do you need water block on the cable where the insulation is removed? And I guess this pertains to both types of cable.
Water blocking is not required. When we use water block, and I think 100% of our underground cable is water blocked, the reason it's water blocked is that we have 100% of that voltage gradient, because underground cable, I have a concentric neutral on the end, so I'm going over a couple of millimeters of polyethylene with 100% of the voltage. So any contaminants that get into the core of that cable are going to try to migrate out through that electric field and cause a failure. There is no voltage gradient across the insulation wall of a covered conductor, whether it's spacer cable or tree wire, unless it's in contact with a ground plane, which hopefully it's not going to be sitting on a tree for long. So no, we don't need water blocking. There's no ionic cell to concern for.
Okay. Another question we have is, what about guying? Doesn't spacer cable require more guying?
The quick answer is yes. It's a heavier system, so yeah, you're going to be guying a little bit more on the dead end, certainly, and also on the angles, so that is a consideration.
Another question has to do with energized restoration, and I'm not sure which slide this is referring to, but the question is, did the crew do energized restoration rubber gloved, or were they hot sticking?
Good question. Two-part question. They absolutely do energized restoration. Utilities do that on a daily basis. They do that all over the Northeast and a lot of utilities across the U.S. Whether or not in the photos I showed they used gloves or hot sticks, I don't know.
Okay, that makes sense. One of your slides showed what appeared to be a recloser connected to the aerial cable. Can connections be easily made using hot sticks?
Yes, we've used every type of switch recloser that is on the market with spacer cable. Connections can be made with hot sticks. It's done every day. Is it easy? I'm not a lineman. I don't know, but whoever is asking that question, you can write in, and we'll get in touch. We'll get you in touch with folks who can answer that question with a little more authenticity than I can.
That sounds good, and it's also a good reminder to any of the folks that are listening in. You are certainly invited to correspond with Brian via email to get questions answered that come up even after the webinar is over. We have another question that has to do with spacer cable being a closed system. And I'm not quite sure what closed system means. The rest of the question was, doesn't it have the same dead end points and equipment taps as tree wire? So does that resonate?
That's a three-part question. So this is what I mean by
I don't mind.
I mean there is polyethylene over that phase conductor anywhere and everywhere on that system, whereas with tree wire, I do have to strip because I can't use my preformed dead end grips over that tree wire. It's fully tensioned. I have to strip it, and I got to strip quite a longitude, quite a distance of that phase conductor. Secondly, do I have to make the same taps and dead ends? Two-part question. Yes and no. Taps, yes. So if I'm making a tap, I have to strip the phase conductor, so I do have a bare point. I can re-insulate that bare point. If I choose not to re-insulate it, I can cover up the messenger. And again, send me in that question. I'll answer that more fully. Thirdly, dead ends. Aren't they the same dead ends? Absolutely, positively not. Tree wire, it's fully tensioned system, got to strip it and use a full tension dead end grip. Any type of dead end grip I'm using on AAAC or ACSR. With spacer cable, no, it is completely covered. A covered conductor goes through a coated preformed dead end and comes out on the pole side and is covered. So it is completely covered. There is no bare point at the end of that phase conductor. And if there was a fourth part of that question, I forget what it is.
I think you said it was a three-part question, so you probably nailed it. This question has to do with the voltages of spacer cables. Do spacer cables come with standard spacing, or can the spacing be changed depending on voltage? So I guess it's the voltage question. And I should add, I was surprised to see a 69 kV spacer cable. I didn't realize it went up to the subtransmission kind of voltages, and that was pretty cool.
Yeah, no, fair enough. At 15 kV, yeah, that we're going to have one spacer, and that's going to be about, I want to say 7-8 inches side to side. At 25 and 35 and 46 kV, we have another spacer, which is 12 inches between the phase conductors. We have a third spacer that you're going to use in super high contam areas that are 18 inches. At 69 kV, our spacing between the phase conductors is about 26 inches, and our future 115 kV system, the spacing, I would have to consult some paper, which is not in front of me. I believe that spacing will be 44 inches between phase conductors.
So
yes,
that answers a part of the. Yeah, that answers a part of the question that I was going to follow up with, and that is what is the maximum voltage for spacer cable? Sounds like it's 115 kV.
Well, today, in all honesty, today we've had 69 kV now running on 21 years, commercial 69 kV, but that 69 kV was tested. Our lab tests were done at 115 kV. We will be introducing 115 kV here at some point in the future. I don't have those numbers or dates in front of me at the moment.
Mm-hmm.
We'd be happy to discuss it should anybody want to write in.
Sure. There's also a question about salt water. What if it gets into the tree wire or spacer cable? And my guess is that, yes, that does come from one of the coasts.
Yeah. Again, we've had spacer cable on the coast since 1951, running right along the coast. I live right by the Atlantic Ocean here in Massachusetts. Spacer cable is run right just above the coast, and if salt water gets into a strip point and migrates down the aluminum, there's not an issue. As I said before, there is no ionic cell, there is no voltage gradient across the insulation wall, there is no tendency for the contamination to migrate to the outside sheath. So there's no concern there.
Cool. This question concerns that there are two different ICEA standards for covered overhead wires. And they're asking if you could explain what the basic differences are.
Yeah, that's a long conversation.
Is that something?
Yeah. One standard, I think, is, if I don't want to quote ICEA S70 or something like this, it's for weatherproof wire. That was when they were using 30, 60, and 90 mil really thin coated wire that ended up to be a total disaster. Blue sky failures, the insulation came off early, and that was a complete disaster. The ICEA was working for the last, I want to say, 10 years on coming up with a new standard. I believe that standard has either recently been published or is up for vote. And in all honesty, I haven't reviewed that yet. That will be sent to me for review. But that will cover 15 kV, and that will have, as a minimum, 150 mils, 3.6 millimeters, as we are using here in Hendrix. So that, if anything, I've seen drafts of that new standard, and if anything, it is a responsibly written standard.
All right. This question asks you to comment on, I guess it's a comment that this person has heard, that spacer cable is good for long straight runs, but not so good for meandering roads with multiple taps for spur roads and transformers and such as that. Would you comment on that?
Yeah, spacer cable is great for straight long runs. Spacer cable is also great for meandering leafy suburbs and national forests. If the person that made that comment would like to be contacted, we can take them for a long meandering drive through past bubbling brooks with lots of foliage, with an angle and a transformer on every pole.
Mm-hmm.
I mean, it's standard construction throughout numerous states here.
Yeah. This question, and we're getting close to the amount of time that we have, is, has the design of the spacer cable supports changed recently in any appreciable way?
We have been making, I don't want to say quantum leaps, we've been making incremental changes over the years. I mean, we've gone from a 3,000-pound cantilever rating on the tangent brackets to a 5,000-pound cantilever rating. We're introducing new brackets that won't break. They'll just bend and spring back. You know, the angle brackets, no, they certainly haven't changed because there's no weight on an angle bracket. All the weight is on the messenger. The dead end brackets are essentially the same, I guess. If they care to submit via email the specifically bracket that they're talking about, I could be able to more intelligently and more comprehensively address that issue.
Okay. I think we'll have to let that be our last question, but the questions that are unanswered we'll get to offline. Before we sign off, though, I'd like to thank our presenter, Brian Trager, as well as our sponsor, Hendrix Aerial Cable Systems, for this webinar. And I'd like to remind everyone that this webcast is an on-demand version of it, will be available on the T&D World website within the next 48 hours and be available for 1 year. So thank you all for having attended. Thank you, Brian, for the presentation, and we trust that everybody will have a super rest of the day.
Thank you very much. Thank you very much, Vito, and attendees. Bye-bye.
You bet. Bye.